Good morning. Welcome to the workshop of the Sustainable Materials for Building. I'm Noni Maravelaki from the Technical University of Crete, and I'm very glad and pleased to welcome all of you in this workshop. First of all, I'd like to thank the speakers of this workshop that accepted this invitation and contributed to the realization of this workshop. Okay, so the Sustainable Materials for Building will explore the role of supplementary cementitious material with a particular emphasis on the specific properties of the novel blends that are derived after the substitution with cement and how those are integrated into the cementitious matrix. And the first presentation is related to what we have learned from past. The second presentation will explore the role of the third mission in these sustainable building materials. Then we will go on with the recycling of aggregates, the recycling with the phosphogypsum in the construction, and how the industrial stakeholders were involved in that process, which are the self-healing processes in the construction materials, and which are the experiences from the PhD students that worked on that subject, and a presentation of the restoration of the Venetian shipyards in Heraklion and Chania, which was the theme that represented Greece in the pavilion of the International Architectural Exposition in Venice. And we were very happy and proud to have these representations from our department, from the Department of Architecture of the Technical University of Crete, and from explanation work that we were all involved, and we got happy to participate in such a great achievement. And least but not last, the relationship between research, innovation, and the collaboration for a sustainable built environment will be presented by the cluster of e-CODOMH system. And we hope that all these presentations here are enrolled in this four pillar of knowledge, which is the research, education, the third mission, and the innovation. Starting from my presentation, then from the past, and how the historical knowledge can be integrated into the modern technology, we will have seen that there is a great need for reducing the cement production. Then there are some points on the terminology of the low ecological materials that have been used in historic masonry, which is the chemistry of mortar plaster towards cement and concrete, some case studies of sustainable construction, and how the past techniques can be integrated into present. These topics will be the main topics of my presentation, and starting from the need for reducing the cement production, it is well known that we are dealing with a great production of about 30 million tons per year, global production, and this production is responsible for 3% of energy use and 10% of the global anthropogenic CO2 that is produced. Therefore, given that Portland cement is widely used in bedded mortars terrazzo, renders, and stuccos, it is important to take into account that we have to go on and to proceed with those supplementary initiatives, and not only that, but with the conservation of monuments. This material is non-compatible with the historical ones. Therefore, there is a need to research and to look for alternative supplementary materials. Regarding the terminology, when we are talking about mortar, this is a mixture of binder, fine aggregates, and water. The fine aggregates are those that have a dimension lower of 4 millimeters. And the concrete is a mixture of aggregates of higher dimension of cement and water. And in this process, the cement with the water is hardening and retains the strength and stability even underwater. When cement is considered as and is reserved to be an hydraulic binder with a low quantity of free lime, we can use the term cement for describing and other hydraulic binders, both naturally and artificial ones. However, the term concrete is referred to those materials that are made with cement, but maybe do not either contain cement, and this is those made by Romans. So, if we go a little bit in past and looking for the lime and concrete use in the construction, we may find the early uses of lime in which it was employed for the interior of different floors and sometimes aggregates higher than 4 millimeters were used. Those aggregates and this mixture is considered as the precursor material to the concrete. Therefore, with the term concrete, we include all the composite materials that serve for a structural purpose, and they are made from a mixture that includes coarse aggregates and binder that is handled. Then, concerning the definition and the chemistry of the air limes, we may see here that from the burning of the calcium carbonate from the limestone, we derive in another type of calcium carbonate in which the microstructure is completely different from the initial calcium carbonate on the limestone. If we proceed with the burning of limestone, but in those materials, we also add some siliceous material, then another very important hydraulic component, the calcium silicate hydrate, was yielding, and this material can also produce at the end calcite and silica after the deterioration process. Similar is happened when we have the natural hydraulic limes in which we have an argillaceous or marlstone, and after the burning we have the production of calcite and the production of those hydraulic phases, which upon deterioration can give again calcite and silica. Therefore, what we have learned from the ancient technology is that when we use hydraulic lime and pozzolanic aggregates, this gives more or some natural additives like straw. Then we can have mortars with a great durability, and if we have a thorough ingredient selection of those mortars and with processing techniques like the soft burning lime, and if we benefit from the layered application and the pozzolanic reaction, then we can develop modern restoration materials and sustainable building practices. Here we have some applications of mortar and plasters during the centuries. You may see here the use of gypsum plasters in the different applications, and how the line with the pozzolanic additives are represented under the thin section study, in which the cohesion and the adhesion between the ingredients is very clear. And in that case, we have the reaction between slate lime and high alkali materials, which can produce hard, durable, and waterproof material. Therefore, we can say that the addition of pozzolanic material to the aerial line, which was widespread by Romans, it was not a Roman discovery, but it was used in different civilizations from the antiquity and produced very hard and durable mortars. So, what we have learned from the ancient mortar technology is the use of local materials and locally sourced materials, which provide compatible restoration mortars, but even they can also sustain the local economy of a place. Then the use of hydraulic lime and natural and artificial pozzolanic materials, which form strong water-resistant compounds, different additives of inorganic and organic nature, the layered application of those mortars, which functions as a composite material, and this helps a lot to the final durable appearance and the consistency of the mortar. And important thing is the soft burning of limestone and the long slating of lime that resulted in materials with good water retention and low shrinkage. Therefore, we have, after those applications, buildings and monuments like here the Great Wall of China, in which it was found that tree bark, volcanic ash, rice, beer, and even green has been used as additives in the mortar preparations. Then we have the domes of the Pantheon, which is an impressive building and an example of not reinforced concrete 2,000 years ago. And we can also found some aqueducts in which the Roman concrete that was used and derived from burnt limestone and volcanic sand shows a very source of longevity here. And finally, what is discovered from specific and explicit studies under the scanning electron microscope is that this ability of Roman concrete was due to its possibility to repair itself over time. And this is totally due to some lime chunks that were inside the structure, and those lime chunks can function as activating points when it was a necessity and produced again calcite. And after this process, they help a lot in the repairing of this concrete over the years. Concluded, we have mortars that are fundamental in constructions and were applied for thousands of years. Those hydraulic binders that have been used from pozzolanic materials enable durable, watertight, and underwater structures. We have lightweight aggregates and early reinforcement attempts that reveal the remarkable engineering skill of that time. Of course, the collapse of the ancient civilizations led to a loss of knowledge and delayed the concrete use of centuries. Nowadays, we have the industrial revolution, revived and advanced concrete with hydraulic cement that mainly shape the modern construction. But we know that the conservation of historic sites requires the understanding of the site and the materials. So we have to produce and propose products that would be compatible to the original ones, and those can be can show an improvement compared to the historic materials, especially under the severe climate change effects that we face today. Therefore, into this direction, the sustainability concerns with the popular cement use highlight the importance of revisiting those historically locally sourced materials and how we can learn from the traditional conduction techniques and how we may integrate those techniques and materials in the modern technology without copying exactly all these recipes, because nowadays we face other more severe problems. And if we are going towards this direction, we may provide some long-term alternative solutions for conservation and construction. Thank you very much for your attention. Now I would like to call the second speaker, Professor Marcin for this presentation. And we will have declarations at the end of the workshop with the discussion today.
Thank you very much for this invitation. I'm truly happy to have a chance to say a few words about the sustainability of the idea of the flagship that we want to just establish. So my presentation will be a bit broader and will show certainly some facts. Will show us also the momentum where we are in the European Union and the momentum where the construction sector is from my perspective. I hope that these numbers that I'm going to show will convince you that this flagship it's really a necessary thing. Professor Maravelaki just started with some numbers, so I decided to start my presentation with some other numbers. So we just heard how much the clinker cements are, let's say, spoiling our air, how much of the gas emissions are connected just with the industry of cement production. But I will tell you some more. Okay? So do you know how much water we need for concrete? We are surrounded by concrete. This is concrete. We are surrounded by concrete. Concrete is the most massive used product in the world ever in the human history. Yes. So how do you think? How much water, clean water, we need for concrete? So I'll tell you, it's more than all humanity use per year to drink. Okay, it's more tons of liters of the clean water. And actually, technologically, this water needs to be very clean. And the humanity, the people in various places in the world, as we know, over 106 million people drink dirty water. Okay, 25%, 2.1 million people, billion people, has regular problems with the access to the clean water. So we use a lot of water for the production of the cement and the concrete itself, and all of the other building materials are also putting some other resources of the water that the other part of society needs just for survival. So we need to stop here and start to think how far we can use actual materials that we for many years thought that we can't live without. Yes, concrete, for example. Still, we just refer here to concrete because we are rather related to concrete, but do you know how much energy and how much water needs the production of steel? Just take a look, please. Okay, so this is also a construction material, and our flagship, as we are part and quite a big part of European University EURECA-PRO. We are working on this together for already 5 years, and we have some successes. There are some projects, project applications, some papers, also some spin-off projects like EURECA-PRO. EURECA-PRO is a project that tackles the issues just mentioned by Professor Maravelaki, also connected with
And just wanted to ask you questions about, because you said you talk about the total amount of water that's used. There is one question, because I'm not cement specialist. What is the wage proportion of water per kilo or per ton of cement? Because the problematic could be either this proportion or the total amount of production of cement in the world.
No, we talk about the production and taking care about concrete, not just cement. We need
concrete.
We need water. This comes to the form.
So my question is, which amount of water do you have per concrete? Because you need water production, but which is this proportion of water you need per ton, kilos, or whatever you want, or by percentage in waste of concrete?
It depends on the material. Depends really on the material, so we can't tell you right now, because for various types of concrete you will have more water, but also in various climatic situations you will need more water, because we need to cure it that it doesn't shrink, it doesn't crack, and so on. I think it's not the time right now, it's not an issue. I just wanted to show you the numbers, and we can discuss details later on. We are limited in time, and I want to show you some other numbers, okay? So if you allow, I'll go on with, I will try. Okay, so just to let you know where we are, and that's why we gathered together many specialists from different disciplines connected with civil engineering and the construction materials. Why do we work? Because as you can see, in Europe, there's around 280 million of buildings. 220 of them is just buildings relatively old, over 20 years old, that they need some interventions, and they were not built with materials that we now consider as innovative materials. So they have issues connected with energy, for example. So please take a look. 85% of infrastructure, built infrastructure in Europe, is responsible for around 40% of European Union total energy consumption, and around 36% of gas emission, greenhouse gas emissions. So it means we use old techniques, we use ineffective construction materials, and we lose a lot of money, we lose a lot of resources, but we also have very, very negative aspects, impact to the society, to all of the stakeholders, to all of us, to our health, and that's what surrounds us, to our children, yes? So the construction sector is responsible for huge emission and huge consumption of energy, which is also responsible for other things that we know. Yes, but from the other side, now we are in the phase of creating new construction materials, various ones. We will talk more about them. Those that they involve less water, less non-renewable resources, less energy, but also increasing durability of the materials and the buildings, extend the life of the buildings. Also, smart buildings, collecting energy, harvesting energy that we can use afterwards. So that's the area that we want, that we are already working together. Self-healing materials, self-monitoring materials, energy harvesting materials, phase change materials. But also, that's what Professor Maravelaki said, the materials taught locally. Yes, we have some materials here we don't need to transport. The clay from UK, we don't need to buy kaolin needs somewhere in Portugal. We can act with this what we have here. It's cheaper and it's effective, and it's so much better than the solutions that the big producers in the world are using now. Of course, we will not be able to provide all of the materials locally, but in many cases we can do this. So that's the aim of our group. So we, as believers in sustainable development goal 12, responsible consumption and production, we believe that this group can really make a huge changes on many stakeholders in Europe. With our innovative materials for renovations, for rehabilitations of buildings, for maintenance of the buildings, the special techniques, low energy techniques for monitoring, preparing, and so on of the structures, but also new innovative materials that I just mentioned. This issue is really, the construction sector is really considered as one of the most problematic in Europe nowadays, and brings very negative impact to the environment. That's for sure. European Commission for many years didn't really wanted to admit it. So the sector of construction, it's relatively abandoned, I would say, by the funds of European Commission. Just now, European Commission started to see the problems with existing infrastructure, with the needs, with the money that we have an environmental impact. So they decided to put some money on that. I will just recall what Noni just said about the Square of Knowledge. Our idea of the flagship bases, of course, on the Square of Knowledge, and the third mission is a big part, but you cannot just spread it. Third mission is far away from innovation, or it's all together. It's just one block. So if Noni is working in the laboratory, it means it will have an impact to the stakeholders. We are stakeholders, you are stakeholders. You are sitting in the building. You will return home, building. You will return using road, bridges, and so on, buildings from outside, structures, concrete, non-renewable materials, energy consumption, and so on and so on. So, in response to that, European Commission decided to help us presently, and they recall the old concept of Bauhaus. Bauhaus was a movement established in Potsdam 100 years ago, and they came with this concept just after World War I, if you don't know the history of this movement, in response to needs of the stakeholders, of the people. Just after the war in Germany, people had no places to live, the country was ruined, so there was an idea of having cheap housing, environmentally friendly, beautiful and functional, simple, small, and close to other facilities, like 15 minutes walk. We know this concept today, 15-minute cities. You go and you have everything around 15 minutes. So that's also the idea. So the new European Bauhaus meant today recalls this idea and brings us the political support, but also brings us a lot of money that are needed for this sector. It joins the sustainability that we are believers, as I said, with something that they call beautiful. So it needs to be generally beautiful, but they don't treat it in the way that this is beautiful. It can be socially beautiful. Yeah, it's much more than that. It's a philosophical question. And we should make it together, which is supposed to be inclusive. The New European values that we are willing to use more and more in our group, it's organized, of course. So the European Commission decided to give some incentives and the money to some places that they think they are needed to be supported. So the first axis is called Reconnecting to the Nature, focuses on restoring of the relationships between the people and the natural environment through sustainable design, biodiversity, and ecological awareness. Nothing about the infrastructure directly here, but behind this, there is a thought about the infrastructure, the new materials, sustainability of the built environment for the people, for the production, and so on. Regaining the sense of belonging. So again, small cities, you know it from France, Le Corbusier, his ideas about unit cities, or 15-minute cities, friendly, green for the people. Prioritizing the places and the people that they need it the most, inclusiveness for those who really need. So behind this idea is, for example, building 450,000 small apartments for the people who have no place to live. It's also to be built with innovative materials, cheap materials like timber, for example, that regains the interest of European Commission. Prioritizing the places, I said this, fostering the long-term life cycle thinking and in the industrial ecosystem. Encouraging circular economy, yes, principles, sustainable production, innovation across the industry within a focus on the long-term impact. Do not leave us alone with these actors and do not give us the money straight. They created some supporting tools. The first of them is called NEP Lab, New European Bauhaus Lab. It's a platform where we already started to belong. Some of us, we started to belong, and we seek for the partners to realize this mission. Also for the partners for the projects. And the second one, it's NEP Facility. New European Bauhaus Facility. It's expressed here. You cannot see it very well, but it shows the interest of the fundings of European University among these three pillars: beautiful, sustainable, together. It's all together. It's all about structures this or other way. It's all about civil engineering, construction materials behind this. The European Bauhaus will support projects as shown here. Community-led place transformation, increasing public acceptance of the clean transitions and democratic processes at the local level, promoting innovation, enabling the change, also the change in the industry, so new materials. And here, if you look through this, what European Commission expressed in the funding programs, you can see clear interest in some of these areas that they are supported by huge money, mainly in the pillar 2 of Horizon Europe. It's circularity and regeneration, reuse of materials, revitalization of structures. So for all of this, we need innovative approach for new materials. Sustainable materials, straight, wood, bamboo, mycelium, prefabrication, functional materials, automation and robotization of construction sector, prefabrication, 3D printing, constructive robot, monitoring, automated monitoring of structures using satellites, for example. Digitalization, building information modeling techniques, digital twin, and so on. Biomimicry, biomimetic approach, so biomimetic materials, self-healing, self-monitoring, energy harvesting materials, energy efficiency techniques and materials, energy storage, phase change materials that I mentioned already. We are already working on that together. Social inclusivity, design for all, accessibility and affordability. So that's behind the European bounces, and that's what we are doing together for 5 years. Actually, each of us alone for 20-something probably or more years. And now we have a chance to work together under auspices of the flagship. So just to show you the momentum we are in European Commission. I will not read it through, you can probably see it later. So these are the money, the programs and the projects that are funded for European boundaries, so directly or indirectly connected with construction and building materials. And that's the money that the European Commission wants to give us. You can see how far the construction sector was neglected. So these are the total fundings in the frame programs of Europe, of European Commission, and these are the money for the construction sector. So it's increasing significantly, but we see how much they value us. But if you see in the numbers how it changes in the consecutive framework programs, you can see that in the last Horizon 2020 and Horizon Europe, this money is increased just for construction. It doesn't mean that we cannot apply for other type of grants indirectly and open. That's what we are trying. For example, doctoral networks. It's not directly connected with the new European boundaries projects. So, leaving this lovely slide at the end, we'll just appeal to your understanding of the need of establishing of this flagship, together with this probably very unique possibilities that we have, this very unique momentum that the construction sector is at the moment. So in my opinion, it would be really a pity if this group doesn't really create something for having this aim in their minds on the daily life under our auspices of the EURECA-PRO. Thank you.
Thank you, Marcin, for this very holistic presentation. The topics of our core group and our aim to establish the flagship in the EURECA-PRO Flagships. I would like to ask now the next speaker, Galetakis, to present the role of recycling the aggregates.
Construction materials.
In the construction fluids.
Okay. Hello, everybody. Thank you very much for the invitation to present research activities related to recycling construction demolition materials. My presentation will be quite more technical. The previous presenter has already focused on the importance of ecological sustainable building materials. So I will focus on specific research activities that have been conducted in our laboratory in the School of Mineral Resource Engineering, and it has to do with the utilization of construction and demolition waste, as well as also of wild finds byproducts for the production of building elements. The content of my presentation has just say a few words about construction and demolition waste, why we choose this stream of waste. Then I will talk more in detail about the research topics we have during this time, the research project which are related with these topics, a publication, and finally some words about lab infrastructure and team. We have chosen to make research with this type of waste because we know that construction demolition waste are by far the most voluminous waste stream in the world. You see here some numbers. For example, you see that the production of this waste in Europe is around half a ton to 1.5 ton per capita annually. And this construction demolition waste does not include the waste from excavation. If we add also the waste from excavation, this number may be tripled. So you see that this is really a huge stream of waste. And it is emergency to utilize this waste by the best of our knowledge. Another also important point is what is the composition of this waste? You see here that the majority of the material included in this waste is mineral matter. It's aggregates or other paste which also produced from mineral raw materials. And this is constitute 80 to 87%, and the rest are wood, plastics, metals, and others. This is why we are so actively engaged in this construction demolition material, because as a School of Mineral Resource Engineering, we have special knowledge and expertise in these materials. Now let's see our research activities up to now regarding the utilization of these construction demolition materials. They are, let's say, can be categorized into two main fields. One is the best, let's say, known because the technology is quite simple and it has been used for long years, is how we can use these construction demolition materials as aggregate. The simplest way to utilize it without having to develop expensive technology or use very low-intensive processes. So this is the first application, to produce aggregates. The aggregates produced from this waste, if they don't have any treatment, it's of low quality. This means that it has to be used only for low-bearing concrete or as backfill material. If we want to produce upgrade aggregates, we have to make some additional treatment. This means that we have to design and construct a more sophisticated crushing sieving system and to separate selectively the mortar and the primary virgin aggregates. And this is a field we have already developed research activity, but we focus also not only the production of upgrade aggregates, but also we have to find a way to utilize the fine waste that is produced during the liberation of these aggregates, because the cement past is much more brittle than the aggregate, so it is forming a very fine fraction which has to be utilized. So another research activity is to find a way to utilize this fine waste material, and one way we have proceeded up now is by thermal activation, just to heat in a temperature of around 600 degrees, and this material became again a kind of cement. So it can be substitute a part of cement in mortars and concrete products. The percentage of these recycled aggregates which can be added in natural aggregates at the moment is limited to, depends on of course, on the quality of the recycled aggregates, to 20%. But even in this quite low percentage, the volume of the aggregates which can be used, the recycled aggregates, is very high, because the demand for aggregates and concrete is very high. Another also research topic that we have in the previous year is how to use the aggregates produced from concrete, from bricks, from tiles, from these construction demolition materials to form common cementitious product like paving bricks, slabs, and so on. We have developed some special technologies based on compaction malting, free flow casting, extrusion, and also a quite more, let's say, innovative, the geopolymerization. The problem here, the challenge is that the recycled aggregates are not as the natural. They have high water absorption. They have not similar shape and texture with the natural aggregates. So we need to develop special models to predict the properties of the new cementitious material and to develop special synthesis mixing models based mainly on packing models of the grains. So this is a challenging work, and the research on this topic is still ongoing. We have also produced some prototypes. We didn't stay only on the laboratory scale, and you see here some slabs we have produced, paving bricks, also some slabs with insulating foam, and some others which has been polished to be used as substitute of common marble tiles. Another problem also that the concrete construction industry face is that the production of fine waste material that is produced during the production of aggregates. This fine material constitutes a high environmental problem, a severe environmental problem, and we have to find solutions how to utilize this material. The solution that we have, let's say, explore and we're at the moment developing at laboratory scale is to produce either artificial stone by compaction malting or self-leveling microconcrete or tiled by extraction or non-autoclave aerated lightweight concrete, microconcrete. On this, I will show you the idea. The lightweight microconcrete is substitute of the very well-known commercial products as autoclave aerated concrete. You know the firm e-CODOMH or something which is similar to this one. So the idea here is we study how this material is produced, and we found that we can substitute the silica sand that is used to produce this material with this fine material from quarry waste, and also to substitute the autoclaving procedure by a normal curing. This means that we have with this modification a low energy consumption process, and we have produced in laboratory scale this material you see here with these pores. And it is something that we are at the moment working on developing prototypes in a larger scale. Also, the ongoing research activities on this field includes the utilization of waste fine material now from asphalt mix plants, another also fine waste which pose severe environmental problems, to develop cement mortars with electrical energy storage capacities. This is why this happened, because this fine waste is enriched in carbon, and this changes its electrical properties if it is treated in the right way. So it can create a kind of battery. This means that we can develop mortars or other cementitious product which can act like a battery in a building. Also, we are working on another on another region, which is to use this fine quarry byproducts for production of lightweight concrete, but not using the common foams that are used for this, but using a foam which is made from carbon dioxide and special chemical additives. And also, we are working on curing this cementitious material on carbon dioxide environment instead of way. This means that the curing using this environment is shorter And we also have a lot of environmental benefits because it absorbs also carbon dioxide from the atmosphere. So the project that has been, that has supported all these activities, you see here, the project we have in the recent years, we have also the relevant publication. And finally, my research team consists of the people you see here. Without the valuable help, it couldn't be conducted all these research activities. So all this from me. If you need, and if you have any questions, I think it's at the end of the session.
Yeah.
Okay, thank you very much.
Thank you, Michail, for this very detailed presentation on the utilization of the waste materials in the constructions. Very important a topic that is entailed in strategic challenge A. Okay, we can proceed with the next speaker. I'd like to ask Cristina to present the safe materials, and then we will continue with the game. Sorry for this.
This one up and down.
You so go to the next.
Yeah, great. So good morning. I'm Cristina Nardi from Cardiff University. So I'm kind of evidence of what is welcoming that was mentioned in the first presentation by Benoit. And I'm collaborating also with Noni Maravelaki. So that's why I'm here. I will keep all this concept very brief because it's a wide range of technologies. But I strongly invite you to type on Google RM4L, which is Resilient Materials for Life. It's an acronym where you can find a nice cartoon on YouTube. So you can laugh and then learn a little bit about these technologies. So where is that working?
You click on the keyboard. Maybe it's put out. It's put out. It's out to USB switches. Take out the USB, the other thing.
Ah, yeah.
Remove the USB off.
That was not connected anymore. Okay. So I would like to just briefly introduce the concept before. Self-healing materials are a class of smart materials which have the inborn ability to repair themselves after being wounded. So they are quite similar to biological organisms or similar to our bodies. When they get hurt, they have the inborn ability to react and to repair, which means for construction material, you have the ability to recover the mechanical properties either in terms of strength or stiffness. So the inspiration comes from biological system. So that's why it's also called a natural-based solution materials. We can't stop aging, we can't stop to have damage, but we can consider a different approach in terms of damage management. So the damage acts as a trigger for the self-healing. So we include the damage as part of the healing process. Among other technologies, which are widely studied in concrete mainly, but also in asphalt or in polymers, I would like to introduce you vascular networks. Again, the inspiration comes from the arterial system in human bodies. So ideally, you can have an arterial system running in your building, and those vascular networks can host healing agents. So ideally, you can have the opportunity to supply different healing agents at different time, or to continually supply healing agent if it is needed. But as you can imagine, the real scale is not yet constructed. So in Cardiff, we have developed an alternative technologies, which is still keeping the concept, but is quite more reliable. And we designed what we call mesovascular networks. They are, again, 3D printed hollow units. They are made by interconnected channels. They can store healing agent inside. So when you have a crack, and the crack crosses one or more of those ligaments, then they are broken, and at that time they can release what was stored inside. So they can store a single component healing agents, basically silicates, or they can also store a dual component healing agent, as more of the most common adhesives are made of two components. They are made by two coaxial channels. So when you have a rupture, the crack also occurs in the matrix. The stress can be transferred to the units. You have the breakage of the units, and only at that time the two components are together and can react in the concrete matrix. We test them in a lab scale at the moment. We place them in the middle third of a concrete prisms. We use sodium silicate as a single component, or the sodium silicate in combination with nanolime or nanosilica, because those second parts can act as a lancer or a promoter of the healing reactions. We test them under Fibonacci test, and we analyze what we call index of healing in terms of strength and stiffness, which is not so complicated. We are just basically comparing the flexural strength after the healing in relation to the original strength before the damage, in relation to the residual flexural strength, which is this one. Okay, so here is how we place them in the middle third. These are pictures when the sample was under load. You can see a clear discoloration in the center, which means that what was stored inside has been released. So it's able to react. Just briefly, if you have a single component, you can recover the strength by means of 70%. If you have a combination of sodium silicate plus nanolime, you can gain by 10% this recovery in strength, and by 20% in terms of stiffness. So when they are together at the time of the damage, they can respond with more healing efficiency. So in conclusion, we can transfer what is done by biological system into construction of material. We have a promising approach, which is based on these mesovascular networks. But I would like to go further, and then to transfer all this knowledge, which is back to the, let's say, 2 decades so far, from newly concrete structures to historic building. And I would like to see how we can transfer some of those technologies in historical masonry structures with obviously the proper requirements. And thanks for your attention. If you'd like to help me, because I was a little bit too tight in time, just send me an email. Thank you.
Thank you, Cristina, for your presentation and for the time that presented us this morning. It's talking about the circuit of and the materials in production. And now we proceed with Wouter and the Phosphogypsum recycling in the construction and how industrial stakeholders could be also involved.
I wouldn't estimate that it's really on how they get to be involved, but at least we're going to consider some aspects of stakeholder involvement. First of all, in brief, we are Center of Environmental Sciences at Newcastle, so we are, let's say, very broad in our approach on looking at all aspects of, in this case, recycling. I will deal with phosphogypsum. I'm just taking this as an example. It's like a residue, as there are many others, like also, for example, if you're looking at non-ferrous residues or other materials, where of course you have a lot of trace elements there that could be potentially problematic. So this type of residue it needs a treatment. And actually also the industry itself likes to have these treatments to get some more metals or other components out of there. So the treatment could, depending on what's present, also generate some added value. Again, here in this case, we're looking at phosphogypsum, and the specific thing which makes it interesting for me is that it also contains trace elements of natural occurring radionuclides. And since I'm actually linked to nuclear technology, I focus on the residues which have this kind of issue, and I try to see how can we deal with that. An important concern is, in this case, this is about the phosphogypsum where you're looking at. If you compare it a little bit from the point of view of natural radioactivity with other types of gypsum, of course, it's very broad. For example, many types of phosphogypsum don't really have any issues with the presence of natural occurring radionuclides. Some have larger issues than others. So, and also, this is just to indicate also for other trace elements or the presence of rare earth elements that very much depends on the process or on the origin of the ores that they use. And this is typical for many residues. There is a very, very diverse picture, and it's difficult to come up with one solution for all of these types of residues. Anyway, as we said, we are focusing at recycling in cement or construction. We are considering alkali activated materials, or in our case also aggregate binders, where even the phosphogypsum can perform a much more, let's say, have a much more beneficial function. So we're looking in general to all types of synthesis binders, and we're looking, are these suitable options for phosphogypsum recycling? And of course, we are technical people, so we think if we can solve all the technical issues, deal with the durability, deal with all kinds of strength-related properties, look at other potential issues like soundness, expansions, and all. If we can deal with all these, we believe recycling will be fine. But is it? And then, of course, one of the main challenges, and I just had a PhD student of mine who graduated actually in this field, and that went really also out of my comfort zone, because we were looking actually at stakeholder acceptance. Because we are thinking, okay, we're calling these residues norm, we're calling this waste, and then we think people are just going to accept it even if we put in a treatment that they are used in cement or concrete. The moment you put a label on it, you're really putting a barrier also for the cycle. And in this case, we look at different types of perspective. I will look at the perspective of industry, and I will tell you why I look at the perspective of industry. You as an end user, are you really going to choose the type of cement for your house? No, you're going to rely on the companies and the subcontractors and everybody else to make that choice for you. But if there is something wrong with these residues, you're going to, or with these materials, you're going to hold them accountable. So that's why the industrial, let's say, acceptance and the industrial point of view is a crucial one. So that is, of course, important. So we looked at industrial stakeholders, and we said, okay, we have these residues. We are just taking phosphogypsum as an example. How would you look at would you accept this type of residues for use in cement in construction? Which are factors that you consider? And I talk about, of course, all kinds of regulatory aspects, let's say. Of course, the quality and performance is important. It would be nice if you can even harmonize that a little bit more on the European level. Of course, customer demand is very important. So, of course, sustainability can be a sales argument, but at the same hand, it can be a drawback or an issue. And then again, if I'm talking about non-ferrous or phosphogypsum, they will have serious questions about the availability. If the scale is suitable, of course, for this type of practices. So what I wanted to say is many non-technical parameters are actually key and crucial to which extent we will make this type of material or this type of recycling happen. And in a way, we Belgians are sometimes, how to say, we are more docile. in a way, the companies say, if we can have regulatory certainty on these issues, then recycling should work out fine. But I can tell you, this is for a Belgium study. We had Belgium stakeholders from industry. In other countries, for example, in Czech Republic, it was not necessarily the case because some, previous bad experiences with specific residues can really screw up a recycling avenue. And regulatory certainty might not be enough. It's about trust, as some of you already presented in previous presentations. So these aspects are crucial for recycling, and that's what I wanted to highlight a little bit with my presentation. And again, it's not only regulatory certainty about the current regulation, but regulations are getting more strict. It takes a long time to develop and to make sure that you reach a certain point of recycling, that you have a good option, you're ready for the market, but regulation has changed. So that is, of course, could be a very problematic aspect. I'm just saying some ways to overcome that, and sometimes for this type of residue, I only see this option. I believe we need to treat, because regulation will change so drastically that we need all kinds of treatments for these residues, and at a certain point to make sure actually that they are not norm anymore, that at a certain point you will reach problems if you don't provide suitable treatment. Also, these treatments will make your residues suitable for construction. So I had tried a long time of trying to get real reuse, so without treatment, but that I found that at a certain point that will go wrong. Things will catch up with you. And anyway, all these treatments will make sure that you will have a much better quality of construction material, which is crucial for this kind of approaches. So I'm not going in depth there. I think I made my key point that I wanted to make. So you look for added value, of course, but unfortunately, you cannot always get added value with dependent on the residue where you're looking at and its properties. So this is basically what I want to tell you. So thank you for your attention.
Thank you, Wouter, for this presentation. That the introduction is another important for which we will have another for this workshop. Very important. Which are the guidelines for upscaling a product and having this collaboration with the companies. Now, I would like to ask Henry Goldmann to express his experiences as this student here in the European and University of Crete. And in my point of view, it's very important for the configuration of and establishment of the flagship to have the support from the business students that important research and can contribute in the formula of the knowledge and so on.
Thank you very much. I am honored to be invited by Professor Maravelaki to give this speech, especially here at the Technical University of Crete, where my journey with EURECA-PRO actually started. I am a PhD student at my last times of PhD at the Salesian University of Technology. I am dealing with construction materials, but especially functional materials, which were already mentioned by Professor Gorsky before. So in my experience with EURECA-PRO, as I mentioned before, started with a few events. The most important events that were also needed for me to acquire a EURECA-PRO PhD certificate, which is also a measure of my devotion and the devotion of my copy to the sustainability. So starting off, as I mentioned before, the first event I had the chance to take place was the PhD journey, which actually like a
few buildings in that direction. The laboratory I've been working with the professor and her assistant. So I was able to acquire more knowledge and to widen my perspective on the topic of construction materials, especially the conservation of construction materials, using mainly nanomaterials and coatings, which is close also to the topic of my research. Maybe so my presentation is not all about the good stuff. Actually, I was not able to meet other PhD students who were dealing with construction materials back then. But anyway, it was a perfect opportunity also to network with some of the other doctoral students. Then I took part in the Young Researchers Colloquium in Freiburg, which was again an opportunity to maybe highlight the topic of the sustainability of construction materials more, because again, my presentation was the only one dealing with this topic among other PhD students who are dealing with different research areas and different challenges. We also received a special training on LCA then, which also sparked my another interest in the topic of LCA in construction materials, which I think is still not very well developed in Poland, and I think it could be a very important aspect in convincing stakeholders to our solutions if we give them strict numbers to our ideas and products. I have also taken part in a PhD seminar, which was again a chance to present my research to a wider community of EURECA-PRO researchers. And this time it was more about connecting with not the PhD students, but also the research community, because I have received a few very valuable remarks and comments on my work, and even some collaborations, propositions which might come to fruition soon, because it helped me to develop a cooperation with Leoben, which could really, in my project proposal for national funding for PhD students. So there is another long-term benefit from it. And of course, I attended conferences, both of the conferences so far, which again were a great opportunity for networking and also highlighting the topic of construction materials and their sustainability, which is of course present on the conference. But I always think that we can always do more, and we can always have more presentations on this important topic. So I hope if the flagship initiative comes to fruition, we will have even more emphasis on the topic of construction materials, which, as again Professor Gorsky mentioned, is not so well recognized in the European Union so far, but hopefully we can change it. Thank you very much for your attention.
Thank you, Eryk, for your presentation and your comments. We have a lot of us to see how we will proceed and improve all of this, the situation in the activities. And now I would like to ask my colleagues from the Department of Aggregation to show us the pavilion, the Greek pavilion in the Biennale of Venice, and to relate it, of course, with the sustainability and the sustainable materials of Crete. Skoutelis and Aslanidis.
Yeah. This is an architect and worked in Technical University of Crete. It's 19 years now. And 7 years ago, we co-founded the Laboratory of Documentation, Conservation of Historical Buildings and Sites
in our polytechnical school. We work between old and modern structure, existing architectural buildings and new architectural proposals. We go between conservation and innovation in big and small scales. And our work involves the work of other laboratories in this technical school and the specialists elsewhere from other sites. Our first line is the Ministry of Culture in Greece and municipalities, especially in Crete. And our last work has been a project for restoration of the palace of the Great Register of SuMaB in Rhodes, or medieval and Venetian and Ottoman fortresses in Peloponnese and the islands in the Aegean. And so this year, with these combined projects, three projects of the shipyards of Heraklion and Chania, we have been selected to represent the Greek architectural culture in the Biennale of Venice and architecture. And Klimis Aslanidis, we present you as this exhibition. Thank you.
Thank you very much. Good afternoon, everyone. I'm Klimis Aslanidis. I will present you our exhibition at the Greek Pavilion in the 19th Architecture Exhibition in Venice. Thank you very much for inviting us here to do this. I was worried that it might not be very closely related to the topic of this workshop, but I now see, I haven't seen the previous presentation, that it perfectly fits, because in fact, it is, I guess, the desire of everybody that all this research on materials is integrated in contemporary architecture. In this case, our proposal for this exhibition was related to the main topic of this year's Biennale in Venice, because the topic, as suggested by the main curator, was intelligence, natural, artificial, and collective. So we thought of combining this notion of intelligence with the notion of history, explaining in which way the continuation of history and ideas developed through history can contribute to the architectural dialogue today. So we exhibited the two projects that we had already prepared for the restoration and reuse for the Venetian shipyards of Crete. One complex is in Heraklion, and the other one is in Chania. And in this case, we presented the two projects together. So in the middle here, you see our proposal for the restoration of the shipyards of Chania, and on the sides of Heraklion, and I'm going to explain this later on. This is the Greek Pavilion in the Venice Biennale, and these are some photographs from the opening of the exhibition. The exhibition started in May, and it will finish on November 23rd, so it's still on. This is the complex of the Venetian shipyards of Chania, built in the 16th century, a completely abandoned building, complex, 7 large vaulted halls, empty now, a part of a bigger complex that consisted of 17 shipyards, very much neglected, right in the very heart of the old port of the city. And this is for parts of an even larger complex in the city of Heraklion, in the historical harbor, that contains a series of four partly collapsed vaulted halls and also other storage rooms built by the Venetians in the 16th century, as well as a big cistern, an empty historic cistern. This is our proposal for the conservation and reuse in Chania, where a large cultural center would be created with minimal, or what I would say minimal interventions in the interior, so as to have a big exhibition area to the left side, as well as a small theater to the right side here of the drawing. So all new, all the historic building is will be conserved with sustainable materials based on the research by Professor Noni Maravelaki, because as already mentioned, this is part of an interdisciplinary work of a very large team here at the Technical University of Crete. So lime mortars and also traditional techniques that were studied during this research are going to be used for the conservation of the building complex, and all new additions will be designed in a way that will create this dialogue with history. And timber will mainly be used for these new additions, especially large timber as the one used by the Venetians in the 60s. So these are here technical detailed drawings showing this use of timber, as well as the use of lime mortars on the walls and on the roofs of the building. And this is the proposal for the shipyards in Heraklion, where also a cultural center will be created, and that we are hoping to regenerate the very heart of the city, the historic harbor that is now very much neglected. Some photographs of the Greek pavilion, a very large model made of timber was built, combining these two projects together and explaining how new constructions are integrated within the old building. And our idea was to create exactly a very big model, because we, on one hand, we want to convince everyone for our idea, but also because we want to stress this idea of focusing on construction and the use of materials in contemporary architecture and exposing this use of materials. So these are different views of the model presented in the exhibition. And in conclusion, I would like to especially stress how adaptive reuse today is a main question for contemporary architecture, and how us architects want to collaborate with, let's say, you experts on materials as adaptive reuse of historic building must give an answer to contemporary architectural questions. Thank you.
Thank you for this presentation and showing us all these nice pictures from the exhibition. And now I would like to ask the final speaker, Biennale, to present this relationship between research, innovation, and sustainability.
Good afternoon to everyone. Thank you very much for the invitation for this very interesting workshop. My name is Dia Andreouli. I am the Secretary General of Cluster E-CODOMH and Head of R&D at MIRTEC. MIRTEC is the Materials Industrial Research and Technology Center in Greece. Today I will present you the cluster E-CODOMH, the first Greek cluster for the construction sector. And actually, I show you the European environment in which the cluster is working. Okay. Let's continue. So I will start presenting you some key aspects of the environment in which the construction sector is working. And the very first is the ambitious goal that the European Union set to have a climate neutral Europe until 2050. And this is through the green, through the Fit for 5 and the green, sorry, how can this is, okay, now we can see everything. And how this can be done through the Green Deal and the Fit for 55. So the European Union set some measurable goals and take some actions in order to achieve these targets. You can see that the first target is to have a 55% reduction in greenhouse gas emissions until 2030. And for the built environment, how this can be achieved. This can be achieved with using renewable energy sources, with increasing the energy efficiency in our buildings. And okay. And here you can see the numbers, how large numbers we have in waste, in energy, because of this construction industry. So construction industry is a key driver in order to have this neutrality until 2050. And this is true not only during the production and the manufacturing phase of the products and the building materials, but we need to take into account also the use of the buildings, the maintenance of the buildings until the end of life, until the demolition or the dismantling at the end of life. So all of these take a very critical, let's say, role in order to have this climate neutrality. Here you can see all the legislations and strategies that the European Union set in order to achieve these goals. We are talking about a very complex legislation landscape. You know some of them, the Green Deal or the Fit for 55, the taxonomy, and all these are supported by other policies, strategies, and initiatives, which then in each country needs, let's say, to be transformed in national strategies, but also in national laws, in order to be harmonized with the European directives. So we can understand that we are talking about a very complex landscape, also because of the legislation that came out because of these new goals. Okay, and you can understand that in this complex environment, the construction industry is a key player, but needs to be transformed, needs to be create more resilient supply chains, more resilient infrastructure, find and adapt sustainable ways of production, be more extroverted, green, digital, comply with all these regulations, okay, but also be more people-centric, which is the new dimension today for the European Union. And here you can see a broader, let's say, picture of the built environment, which is based on the, let's say, of the vision of BPIE, which is an organization in Europe. And according to this, you can see that what we are expecting for the buildings tomorrow. They need to be healthy and foster well-being, be part of energy systems, to be high energy efficient with no fossil fuels, be circular, be resilient, and all this, in order to be achieved, we need to have together a lot of stakeholders from the whole value chain and, let's say, policymakers from the state, the manufacturers, the engineers, the local authorities. All of these need to collaborate, speak the same language in order to understand the way that can work together and reach the set goals. So the European Union understood the importance of the built environment has for the sustainability, for a sustainable future, and created the Build for People partnership together with two strategic organizations in Europe, the ECTP, the European Construction Technology Platform, and the World Green Building Council. And all these, let's say, working together for helping the research and innovation to reach the market and fulfill the new challenges. The two main challenges, you can see, are, of course, to be more sustainable and resilient, but also be more people-centric. And for that reason, today we need to take into consideration not only the technological part, but also the societal part. This is the difference with the old European programs. And for that reason, these kind of links, let's say, are supported with, by innovation clusters. The innovation clusters today need, let's say, to connect all these four groups. We have the public authorities, the industry, the academia, but also the society, the citizens. And the clusters are trying to promote multi-layer connections and collaborations between all these groups. In Greece, we have the cluster e-CODOMH, the Greek cluster for the construction sector. It is located in the central part of Greece. Next. Okay, here you can see, and next one. This is a non-profit company, Cluster e-CODOMH. It was founded in January 2022. It is the first Greek innovation cluster of the construction sector in Greece, and the facilitator of cluster is Tech, which is actually the coach and enabler of this cluster. Here you can see the partners. We have two business partners, two types of members, sorry. Business partners, which are industries, large industries, but also SMEs, but also associate members. As associate members, we have 8 public research organizations and universities in Greece, but also an industrial association. And we are trying to make all our members to collaborate. Okay, the vision is to become an innovative ecosystem for the Greek building materials and construction sector. Our mission is to upgrade actually the entrepreneurship for the companies in Greece, working under 4 pillars: the quality, the innovation, the knowledge, and the synergies. But actually, today we need also to be transformed and include also the society. So we are trying to develop closer links also with the citizens. Okay, here you can see the strategic axis that we are working: business innovation, sustainable development, industrial research and innovation, training and upskills for our members, networking and access to finance, but also regulatory guidance, testing, and certification. Here you can see the thematic focus area, which developed from, let's say, from our members after some workshops and collecting their interests. Here you can see the list. We're talking about new building materials, digitalization, 3D printing, precast building, green buildings, and circular economy. But this is a work in progress as their interests are, let's say, changing as the years come. And actually, we are trying to promote the active collaboration between our members, and we participate with them in funding projects. Here you can see the first national funded project which implemented by our members. It was a national project. In this project, our members collaborated, industry, academia, and developed some innovative building materials. And all of them were demonstrated in a demo building. Here you can see the building, which is used not only for demonstration, but also in order to perform and study the performance of these innovative materials during the real conditions. And we continue. Today, e-CODOMH has been integrated in the European ecosystem. It is a member of ECTP, the European Construction Technology Platform from last year. ECTP is a very, let's say, strategic organization. It participates in safety. So we are happy to be part of this organization. And, next slide. And from last March, e-CODOMH is also a Build for People innovation cluster. Through the Starlight project, we have the opportunity to become officially a cluster with other Build for People innovation clusters in Europe in order to collaborate and build our maturation, let's say, on the way we can add value to our members. Here you can see the Starlight project. The Starlight project is, let's say, it's a CSA action project, but builds on the synergies between NEB, the new European Bauhaus that was referred by Professor Goldmann before, and the Build for People partnership. So these two are, let's say, are the priorities in this collaboration scheme. And here you can see that in this consortium, we have the collaboration between clusters like e-CODOMH, but also innovation experts from other countries, construction associations, platforms, public entities, but also consultants and SMEs. So we are happy that e-CODOMH has entered in this ecosystem in order to bring some best practices also in Greece for our ecosystem. And why we want to be there, here we can see some of the benefits. First of all, we can communicate key messages to the European Union directly. We can increase the visibility also for our members. We can use all the tools that are developed in this project. And closing, we say that the only way forward is based on synergies and innovation through collaboration. So at e-CODOMH, we continuously try to build on collaboration, to build on synergies, with our members and with other stakeholders in order to have a more sustainable built environment. And this is the last slide. As we continuously build on these links, we have the organization of the first conference of e-CODOMH. It is organized for 11th and 12th November in Athens. You are invited. You will be happy to have you all. Please, you can scan, you can visit the website. In this conference, we have, let's say, invited speakers from European Union, from Greek industry, from authorities, but also from research, from universities. And we want to open a dialogue between all these stakeholders in order to start communicate all the challenges, but find the way to reach all these goals together. Okay, thank you very much.
Thank you for this presentation and this vision of the collaboration between the industry and the university and thematics like research and innovation. We have time from some 2 or 3 more questions before going for the answer or comments.
Ask also the remote audience.
Yes.
Yes.
Well, I'm a presentation of the Muslim and I really enjoyed it. Yes, Professor explained well about like where material, the non-invest material especially. And you also shed some light on the past to the present, how we can bring the past to the present. Usually most of the research is done on the waste material, incorporating edited materials, the cementitious material and completely so on. So my question especially to you, like why we bring the past to the present? Why not we bring the modern techniques to the present and we can enhance our material to make it more sustainable? Because we should learn from the past, of course, but we should use the present modern technology, like self-healing and grease. We have very good topic on it. It's modern technology. So while I am lying and other things, we should bring it to the present and then work on it. Why not modern technology?
Okay, thank you for the question. The question is why we have to rely on the ancient technology and not to proceed directly with what we have up to now and to look for enhancing our technology, our nowadays technology. Yes, it's an important point, and my answer to that is, of course, we have a lot of means in the modern technology that we can improve more and go on. But all these materials are associated with an energetic demand which is high. This is the main point. Even the cement production requires a high heating comparing to other materials such as lime or the waste materials that are proposed. And therefore, what we would like is not to abolish the use of the new technology and what the modern materials offer us, but how we can combine both of them. This is our target. Of course, to maintain and improve what we have up now. And we are very good at that because we have a lot of achievements. And for example, we cannot think to construct a skyscraper using Roman concrete. we have to reinforce it with reference to everything. But we can think of using this technique that was applied with the scratch corridor, but at the same time to reduce the participation, the content of the cement inside this measure as in a quantity that could be fit with this sustainability issue. This is the point. Not to avoid the modern technology.
If arise another question, like let's suppose if we incorporate all these materials to make it more sustainable, can we journalize it? Can we globalize it? Because you see there is only limited to the laboratory work. They cannot implement it practically. Like let's suppose that we use some additive materials to the concrete. It's only limited. We cannot generalize like the use of plastic, the use of other materials. We didn't see like such huge roads or huge buildings which are constructed with the little materials. Yeah, we did a lot of experiment in the labs, use different materials as a replacement, partial replacement, fully replacement, 50%, 20%. But we didn't see the practical implementation of it. Like we are not implementing on country level, on global level, and regional level.
Yes, and at this point, what I plan to add is that we have a global implementation. One example is the cement LC3. And this is this mixture of a limestone calcined clay cement, in which we have a substitution up to 40% of the cement. And we have companies like Napals that produce this kind. The point is that all these techniques are based on the use of local materials. Therefore, if we continue into this direction, then we can have the globalization because we can find these materials elsewhere. So I think that indeed we are in a good segment, but what we need more is to assess those materials and to create this benchmarking in a more larger way. You are right. We are not in an advanced state with that, but we can develop and we are in this direction. Sorry for. Another question, comment before starting for the last we will discuss. Yes, I'm very.
Any questions from the remote participants? Here is your chance.
For comment.
Otherwise, we can go to lunch. We're already late. Yeah.
So we'll have to go for the.
Okay. Since we're running a little bit late, we're running about 40 minutes late.
Yes.
Let's go to lunch and be back here at 2:45 instead of 2:30. Okay.
Thank
So,
you very much.
So we're going to push, okay, the rest of the program by 15 minutes. Okay, that's for the remote participants.